Now, in today's class, we are going to learn how to find the derivative of a logarithmic function, that is natural log function, okay? So, in our previous class, don't forget, we learned how to decompose a complex natural logarithmic function. Let's start with the simplest one. Find the derivative of the natural log of x. Okay? Now, to take the derivative of a natural log function, the first step is that we are going to take the inverse of the function in the front of the natural log. The inverse of the function in brackets. You can see in the front of this natural log signs, the inverse, the function here is what? X. So for this, I'm going to have 1 over x. 1 over x. Don't forget that inverse also means reciprocal. You understand? So I'm going to have 1 over x multiplied by the derivative of the function inside the bracket. This sign means derivative. You understand? So the derivative of x is what? 1. For this, I'm going to have 1 multiplied by 1 over x. So this is what? 1 over x. That is why every time we take the inverse of ln x, every time we take the derivative of ln x, the derivative is what? 1 over x. Do you understand? So let's proceed to another one. Find the derivative of ln x squared. Okay? We are told to find the derivative of this function. The first step is that we are going to take the inverse of the function in the front of the natural log signs. You understand? So the function in the front of the natural log sign is what? X squared. So the inverse of this function is 1 over x squared. Do you understand? The next step is that I'm going to take the derivative of the function inside the bracket. The derivative of the function in the front of the natural log signs. So for this, I'm going to have multiplied by the derivative of x squared. If you differentiate x squared, you are going to have what? 2x. So for this is what? Oh, x squared. For this is 2x over x squared. And this is it can be written as what? Because we have x here, we have x squared here. This is what? 2 over x. Because 1x will cancel 1x in this x squared that we have at the base. Just like if you have 2 multiplied by x over x multiplied by x, that is 2x over x squared. Oh, sorry, 2x over x squared is equals to 2 multiply x multiply x. So 1x will cancel 1x. This is what? 2 over x. Do you understand? So that's it. Now let us proceed to a more complex one. Find the derivative of ln x squared plus 5. Okay? Now, we are still going to follow the same approach. The first step is that we are going to take the inverse of the function in the front of the natural log sign. So we are going to take the inverse of this function, that is 1 over x squared plus 5, multiplied by the derivative of x squared plus 5. Just put the derivative sign. So for this, I'm going to have 1 over x squared plus 5, multiplied by, if you differentiate x squared plus 5, that is 2x. So I'm left with what? 2x over what? X squared plus 5. Now I want you to try this. Find the derivative of ln x raised to the power of 3 plus 4x. How do you find the derivative of this? Pause this video. After that, check the answer when you are done. For this, I'm going to have 1 over x raised to the power of 3 plus 4x multiplied by the derivative of x raised to the power of 3 plus 4x. That is what? 2x squared plus 4. So for this, I'm going to have 2x squared plus 4 all over x raised to the power of 3 plus 4x. That is the derivative of this function. So you can see how to apply how to make use of logarithmic differentiation to differentiate a function. Now let's try another one. Let's say we are asked to differentiate y is equals to x raised to the power of x. How do we differentiate this function? I want you to try this. Then I will award to you. If you get the answer right, I'm going to give you a gift. Try it. The first person, I'm talking about the first person to get this right. The first step here is that you are going to take the natural log of both sides. You understand? You cannot solve this without taking the natural log of both sides. But the easiest way to go about this, to find the derivative of this, is to take the natural log of both sides. So for this, I'm going to have ln y is equals to ln x raised to the power of x. Do you understand? The first step is that you are going to take the natural log of both sides. So after taking the natural log of both sides, don't forget that from the law that we discussed, if we have the natural log of x raised to the power raised to an exponent, that will be the power multiplied by the log. Is that not it? That is one of the logs of logarithm. So for this, I'm going to have natural log of y is equals to what? X multiplied by ln x. Do you understand how I got to this point? Based on this law, you understand? The first step is that I take the natural log of both sides. The natural log of y is equals to the natural log of x raised to the power of x. Then I make use of this law. So I've not done anything. Okay? So now, from the left hand side of this equation, okay, the next step is that we are going to differentiate both sides. Okay? So don't forget that the derivative of ln x is what? 1 over x. Abi? Derivative of ln y will also be what? 1 over y. Do you understand? So the derivative of ln y here is what? 1 over y. Do you understand? I've differentiated the left hand side of this function. So let's proceed. Is equals to x ln x. Now let me ask you a question. You are given to take the derivative of x ln x. Which rule are you going to employ? The chain rule, first principle, the product rule, the quotient rule, or which rule are you going to employ? That's not the correct answer. You are going to make use of the product rule, because the sign between x and ln x is the product sign. You understand? So you see, one thing about differential calculus is this: all the basics rule. You can be given a question whereby you are going to use all these rules that we have already discussed. You are going to use it in that question. You understand? So let's proceed. Let's use the product rule to differentiate the right hand side of this equation. So let me just write it in this place: x ln x. So for this will be what? U, and this will be what? V. Do you understand? And from the product rule, we know that when we are asked to differentiate a function that has two parts, and these two parts are multiplying each other, we are going to make use of the product rule. Such function is this: x ln x. So I have uv. For this, I'm going to have the derivative of u multiplied by v plus the derivative of v multiplied by u. That is the quotient. That is the product rule of differential calculus. So for this, u is x. So I'm going to take the derivative of x. Derivative of x is what? 1. The reason why I'm going back to this point is because I knew probably you didn't understand how to make use of the product rule to differentiate. You can watch go back to the previous class that we did. Okay, so let's quickly differentiate this. Derivative of u, derivative of x is what? 1. Derivative of v multiplied by v. So 1 multiplied by what? Ln x plus derivative of v. If you differentiate ln x, you are going to get what? 1 over x multiplied by u. So u is what? X. For this, I'm going to have 1 multiplied by ln x, that is ln x, plus x over x. Abi, that is what? This will be equal to ln x plus 1. So the derivative of x ln x is what? Ln x plus 1. Do you understand? So for this, I'm going to have ln x plus 1. Okay, let us proceed. I want to show you the step how we arrive at these answers. The derivative of ln x is equal to 1 over x. Don't forget that if we have ln x, the derivative of x is what? 1 over x multiplied by, the derivative of ln x is 1 over x multiplied by the derivative of x. So the derivative of ln y will be equal to what? 1 over y multiplied by the derivative of y. Do you understand? So this is 1 over y, and this will be equal to what? 1 over x. But I need this entity. I need this second part. You understand? So I'm going to have derivative of y multiplied by 1 over y is equal to what? Ln x plus 1. Do you understand? Please, if you didn't understand, you can watch the video from this step. Watch it from this step. The reason why I put this derivative, the reason why I put this derivative is because if you differentiate ln y, this is the step before we arrive at what? 1 over y. But I only put 1 over y here, you understand? But I also need to put this derivative because I'm looking for the derivative of y. Are you getting it? So that is the reason why I go back and reverse this and I put this here. Do you understand? So let us proceed. Now, having gotten to this point, the next step is that you are going to multiply both sides by y. You understand? For this, we can write this as derivative of y over y is equals to ln x plus 1. Do you understand it? So for this step, we can multiply both sides by what? Y. If you multiply this by y and you multiply this by y, this y will cancel this y. So I'm only left with what? Derivative of y. Do you understand? So I'm going to have the derivative of y is equals to ln x plus 1. Oh, sorry, ln x plus multiplied by y. But y is what? Y is x raised to the power of x. Do you understand? So I'm going to substitute y as x raised to the power of x. Do you understand to this point? Therefore, the derivative of y will be equals to x raised to the power of x into bracket 1 plus ln x. So that is the derivative of y. So you can see how I simplified it. If any one of you got this answer, raise up your hands. You're a liar. You didn't get it right. So that's the derivative of y. So now, I want you to try this. You can attempt this, okay? Y is equals to 2x raised to the power of 2x. I want you to attempt this. You are still going to use the same approach. The first step is that you are going to take the natural log of both sides. After that, you differentiate both sides. Then after that, you multiply both sides by y. Then you substitute the value of y. That's it. Okay? So now, the first step is that we are going to take the natural log of both sides. So I'm going to have ln y is equals to ln 2x raised to the power of 2x. Abi? So according to this rule, the log of a power is the product of the power and the log. So for this, I'm going to have ln y is equals to what? Is equals to 2x, Abi? 2x multiplied by, 2x ln 2x. Do you understand to this point? According to this rule, the log of a power is the product of that power and the log. Now, we have gotten to this point. The next step is that we are going to take the derivative of both sides. Do you understand? We are going to take the derivative of both sides. Now, take the derivative of ln y. The derivative of ln y is what? Derivative of y multiplied by the inverse of y. Do you understand? So, for this, as you can see, as I express it here, you see, I didn't show this step. I didn't show this step in this place. I just jumped to the conclusion, but I realized that I have to put this in this place. That's the reason why I showed this step. Okay, so let's proceed. So the derivative of ln y is derivative of y multiplied by 1 over y, and if you take the derivative of y, it is 1. So, but it is very important that we retain the derivative of y because we are actually looking for the derivative of y. You understand? So that's it. Now let's proceed. Now, to differentiate the right-hand side of this equation, we are still going to make use of the product rule, okay? So let's differentiate it using the product rule. This is what u, and this is what v. Now, derivative of this using the product rule is what? 2x multiplied by 2 all over 2x plus ln 2x multiplied by 2. Do you understand how I got this? Do you understand how I got this? No, this is ln 2x, so ln 2x multiplied by 2. It is very, very simple, okay? This is what I do. This is what I did rather. We are told to differentiate 2x ln 2x, Abi? This is what? V. This is u. And this is what? V. According to product rule, derivative of u multiplied by v plus the derivative of v multiplied by u. So derivative of u is 2. V is what? Ln 2x. So that will what? Multiplied by ln 2x plus derivative of v. If you take derivative of v, you are going to have 2 over 2x, Abi? 2 over 2x multiplied by u, that is 2x. That's how I got this. Okay, do you understand? You understand now? If you didn't understand, kindly revert back to our class on product rule. Okay, so let's proceed. For this, I'm going to have the derivative of y is equals to, no, derivative of y over y is equals to, so derivative of y over y is equals to 2x multiplied by 2, that is what, 4x. So I'm going to have 4x over 2x plus 2 ln 2x. Do you understand? That is 2 multiplied by ln 2x, that is what, 2 ln 2x. Now, we are having 4x here, I'm having 2x here. I can reduce this as what? 4x divided by 2x, that is 2, abi? 2 plus 2 ln 2x, abi? Now, the next step is that we are going to multiply both sides by y, because I'm not looking for derivative of y over y, I'm only looking for derivative of y. So in order to eliminate this y in the denominator, I have to multiply both sides by what? Y. So for this, I'm going to have multiply by y, and this multiplied by what? Y. So this y will cancel this y. I'm left with what? The derivative of y at the left hand side of the equation. So I'm going to have the derivative of y is equals to 2, which is 2, let me just put it in brackets, 2 plus 2 ln 2x multiplied by 2x raised to the power of 2x. So this is the derivative of y. Find the derivative of y is equals to 5x raised to the power of 5x. You can see that all the examples that we have been doing are consistent. That is, they are similar. You understand? So now let's proceed. The first step is that we are going to take the natural log of both sides. So I'm going to have ln y is equals to what? Ln 5x raised to the power of 5x. I'm very sure you understand the previous example that we did. If you didn't understand, it's very, very important that you pay attention in this place, okay? So take the natural log of both sides. After that, don't forget that the natural log of the log of a power is the product of that power and the log. That is the rule that I use on the right hand side of this equation. That is ln 5x. Do you understand? According to this rule, the log of a power is the product of that power and the log. Now, we have gotten to this point. The next step here is that we are going to take the derivative on both sides. You understand? So, differentiate ln y. And I've already explained it. Ln y is what? 1 over y multiplied by the derivative of y, which is equals to 1 over y. But for the sake of the derivative of y, I'm going to use this. So I'm going to have derivative of y multiplied by 1 over y is equals to, now differentiate the right hand side of this equation. We have two parts, and these two parts are multiplying each other. So we are going to make use of the product rule of differential calculus. So differentiate this using the product rule. What are you going to get? Don't forget that this is u according to product rule, and this is v. And the product rule says that derivative of u 5 multiplied by v, that is ln 5x, plus the derivative of v, that is 5x over that is 5 over 5x multiplied by u. Multiplied by u, that is 5x. You see, this is very, very simple. The only thing that you have to understand is that when you are dealing with differential calculus, all these symbols are interwoven. Maybe for the sake of understanding, let me just give you a good explanation of what I did. Okay? Now pay attention, okay? We have 5 ln x, 5x ln x. We want to differentiate this using the product rule of differential calculus. 5x ln 5x. We want to differentiate this using the product rule. This is u according to product rule from our previous class, and this is v. You understand? Those are the two parts that we have. And according to product rule, the derivative of u multiplied by v plus the derivative of v multiplied by derivative of v multiplied by u. This is the product rule formula. This is the formula of product rule. And we have already identified our u as this and our v as what? Ln 5x. Now, derivative of u is what? Derivative of 5x. If you differentiate 5x, you are going to get what? 5. Abi? Then v is ln 5x multiplied by ln 5x. I have ln 5x plus this additional sign, derivative of v. Don't forget, if you differentiate ln 5x, derivative of ln 5x is what? We are going to take the inverse of 5x multiplied by what? The derivative of 5x. And if you differentiate 5x, you are going to get what? Let me just put it here. The ln 5x, derivative of ln 5x is equals to the inverse of 5x multiplied by the derivative of 5x. Just like the laws. This is the basics law, you understand? So you are going to apply these laws anytime you want to differentiate a function that looks like this. You understand? So derivative of 5x is 5. So I'm going to have 5 over 5x as the final answer. So for this, I have what? 5 over 5x multiplied by u. U is what? 5x. So I'm going to have 5x here. So for this, I'm going to have 5 ln 5x plus 25x over what? 5x. So that is how I arrive at this answer. That is how I arrive at this. You understand? So please, if you didn't understand what you have learned so far, what you have learned from our previous class, it's very, very important that you reverse back. So let's proceed. For this, I'm going to have derivative of y over y is equals to 5 ln 5x plus 25x over 5x. You understand? So now, from this point, and don't forget, 25x divided by 5x is what? 5. You understand? So instead of writing 25x over 5x, I'm going to erase this and put 5. Yeah. So the next step is that I'm going to multiply both sides by y because I'm only looking for the derivative of y. So in order to eliminate this y at the denominator, I'm going to multiply both sides by y. You understand? So this y will cancel this y. So I'm left with what? Derivative of y, which is equals to 5 ln 5x plus 5 multiplied by y. Don't forget that y is what? 5x raised to the power of 5x. So I'm going to substitute it. 5x raised to the power of 5x. So that is how to take the derivative of a logarithmic function. Now let's proceed to another question that is different from this one, though it is still under logarithmic differentiation. So